Good afternoon all. My name's David Chadwick. I'm the chair of the Eastern branch of the Guild. It's my pleasure to welcome you here today to today's webinar, which is entitled The Development of a Certification Scheme for Plastic Pipe Weld Inspectors by the Welding Institute. Before we start, just a couple of points just to reiterate what Kate has said about please turn cameras and audio off. Please be aware that the webinar will be recorded. Please post your questions on the chat facility and we'll be picking those up at the end. If we do have time, we will open up for a general discussion at the end, but we do have to be finished by 1 o'clock. So that's enough from me. I'll now pass on to Scott, who's going to start off the presentation. Over to you, Scott.
Thank you, Dave. Good afternoon, everyone. And firstly, I'd just like to thank Dave and Kate for organising the event and for the Pipeline Industries Guild for having us at TWI. We've spent over 2 years developing this certification scheme for plastic pipe welding inspectors. So really pleased to be able to share the work that we've done to get to this stage and the fact that we launched the course last year and how we plan to move it all forward. So I'll just introduce myself. So my name is Scott Andrews. I've been at TWI for over 20 years. I'm actually a principal project leader within the novel polymer technology section. My main roles are delivering projects on research and development in plastic welding. And I also manage the day-to-day running of the plastic welder and plastic weld inspection training and certification scheme at TWI. So I'm going to give you a brief overview of TWI, the training and certification scheme at TWI. And then I'm going to hand over to my colleague, Tony Grouse, who's going to give you a bit more information about the development of the certification scheme and what it entails and what the candidates can expect when they attend that course. So this is just an agenda that I put together. So introduction to TWI, which I'll give very brief. Obviously, some of you may know about TWI. I guess some of you don't. So I'll give a brief overview into TWI and our TWI training activities. An overview of our plastic welding training activities, because obviously that's a bit of background information that led us into developing this scheme. Why did we develop the certification scheme for the training course? Obviously, that's really important, a bit of background there. And then I'll hand over to Tony, who's going to provide more information on the development of the certification scheme, what the course content is of the certification scheme, what the candidates can expect to learn on the scheme, and then obviously what they need to do to pass the exam at the end of the training course. And then, of course, obviously, the perceived benefits of the plastic welding inspector training scheme. So for those who don't know, what is TWI? Well, TWI is primarily a research and technology organisation. We obviously do other things as well, but we're primarily research and developments. We are membership driven, so we have approximately 800 industrial members at TWI across many different industry sectors. So that's from anything from aerospace, automotive, oil and gas, medical, construction, for example. And we're non-for-profit, so that means any money that we make in the business goes back into the business in terms of research and also in terms of staff costs and things like that. One thing I should mention is that the way the membership model actually works is that we take a fee from those members, and some of that fee then goes back into core research at TWI. So that allows us to hopefully stay ahead of the game and put a few million each year into core research. We have approximately 750 staff globally, and mostly it's cross-sector innovation. So although I work in plastics welding, I might be working on a medical device one day and then a plastic pipe the next day, and then a part for a car the following day. So obviously all the research that we do is cross-sector. So we have 5 UK research centres, starting at the top. So from Aberdeen is mainly training, so where we do non-destructive testing, inspection and welding on the metal side. So we don't have a plastics presence up there yet, I should say. In Rotherham, we do a lot of laser additive manufacturing and friction stir welding. Again, metals based really. And in Middlesbrough, we do have a plastics. We have our main plastics welder training centre in Middlesbrough, but we also do a bit of finite element analysis, manual welding, underwater welder training. So we have a big dive tank there for underwater welding. And Port Talbot is where we do most of the non-destructive testing development work, I would say. So not training, just mainly development work. And then Cambridge is where I'm based, which is the headquarters, and that's where we do a lot of structural integrity research, welding research, non-destructive testing, and where we house some of the innovation centres. Training sites that we have globally, we have many. So these are all the sites that we currently have training facilities where we can deliver welder training, non-destructive testing training, and plastics welder training. So we're just going through the process now where we are actually rolling out plastics pipe welder in Malaysia currently. So we've just gone through a trainer scheme with our team in Malaysia. But you can see we have a presence in most parts of the globe. And if we don't have a presence with the training centre, we quite often will have agents in that area that can pick up work for us. Now, I asked our membership team just to give me one slide on just to summarise what TWI does, and hopefully this is what it does. So I'll just read through this if you don't mind. So to provide our industrial members with authoritative and impartial expert advice, know-how and safety assurance through engineering materials and joining technologies. And obviously within that, we will cover anything from welding and joining, and that's all materials, structural integrity, materials and corrosion, surfacing and non-destructive testing. So like I say, most of the research and development we'll carry out for our member companies, but things like training and certification and collaborative projects, things like Innovate UK or European funded collaboratives, we can do for non-members. This is the final slide on TWI, where this is the sort of work that we would do. So we would like to get involved in projects right the way from initial concept, brainstorming, modeling the product or process, material selection, right the way through to pre-production, where we offer training and certification on the product, from procedure development in terms of manufacturing, troubleshooting, where we'll go, and if people are having issues with welding equipment or production welding, then obviously we'll go there and try and offer advice and guidance, right the way through to decommissioning and end-of-life recycling as well. So the TWI training and certification business. So TWI is the largest provider of welding technology inspection related training for individuals and companies. We approximately train 20,000 people each year across the business, and that's across all of those training centres that I showed previously on the slide. More often than not, the training courses will lead to an internationally recognised qualification. And for plastics in particular, that qualification scheme is a CSWIP scheme, and the courses are designed to service all key industry sectors. So, and what I've done there is I've just put a list of the most common training courses that we deliver at TWI. So you can see, obviously, welder training, B-gas, underwater inspection, non-destructive testing, international welding diplomas, and then obviously the one that we're here to talk about today is obviously welding inspection. So a little bit more background into the welding inspector scheme. So currently for metals, there is approximately 40,000 CSWIP certified welding inspectors operating worldwide. And we certify approximately 9,000 welding inspectors across all the levels each year. So you can see the numbers are quite large. The 3 levels of certification that we certify them to is a CSWIP visual welding inspector, which is the entry level. The next level is CSWIP welding inspector. And then the highest level is CSWIP Senior Welding Inspector. And again, to reiterate, this is all for metals, inspecting metal welds. And many contractors and specifications now cite that CSWIP certification is a requirement for welding inspectors. So obviously, if anyone who wants to have a career in this field needs to have obviously a certification, and obviously CSWIP is obviously quite large in that field. And why is it important? Well, it's a mechanism of proving an individual can work to a safe and professional standard, whilst also helping to reduce the cost and time spent on reworks and repairs. So plastics welder training and certification at TWI. What do we currently do? What have we been doing? So we've been running these courses for approximately 20 years now. I think it was late 90s that we started developing plastics welder training courses and certification courses. The certification that we run these courses to is mostly in accordance with BSEN 13067, which is the qualification testing of plastics welders. And we approximately train and certify around 250 individuals each year in plastics welding. And that would be, although pipes is our largest market share, we will also do fabrication, which is hot gas and extrusion of thick sheet, which covers things like the manufacture of chemical storage vessels, and also lining systems, where we're looking at wedge welding and extrusion welding of thin membranes. And that's typically for landfill works, anaerobic digestion plants, rainwater harvesting, those types of applications. And all of those courses will lead to certification and individuals gaining a certificate to BSEN 13067. And the two at the bottom there, so these are the ones that we're going to talk about now. So the Plastic Pipe Visual Welding Inspector course and the Plastic Pipe Weld Inspector course. So why did we develop the scheme for Plastic Pipe Weld Inspectors? Well, obviously, hopefully from the previous slides, you've seen some of the numbers that we currently train and certify for metal welding. So we know, obviously, from experience that use of plastic pipes is increasing significantly. And we also know from some of the research we've done from some of the metal welding inspectors that have attended our courses is that existing welding inspectors are being asked to inspect plastic pipelines with little knowledge. So we're getting this feedback regularly that they're being asked to inspect plastic pipes with their metal welding qualification. So obviously that's not an ideal situation. We're seeing a significant demand for trained plastic pipe welding inspectors, in particular from overseas, actually, from oil and gas overseas. So there's one or two Middle East, very large oil and gas companies which want to specify this scheme as soon as possible. So we're working with them now to develop training centres locally and set up this certification scheme there, so they can adopt it. We obviously know that leaks in plastic pipes are hazardous, can cause significant damage, costly to repair. This is a statistic that I pulled out, which is obviously there's 2.9 billion litres of water was lost each day in 2020. Now, admittedly, not all of that was from plastic pipes, and not all of that was from the joints of plastic pipes. However, a significant proportion would be. And we also know that the majority of leaks will occur at the joint line. So ensuring integrity of welds in plastic pipes is really important to addressing failures and leaks in those systems. Now, for the metal industry, weld inspection has always been the first line of defence against poor installation, and we're hoping that now we've developed this scheme and we have this in place, that this will be the first line of defence against poor installation going forward as well for plastic pipelines. We began developing this scheme in 2018, and it took us 2 years to develop it. And unfortunately for us, we actually launched it. We had a big launch planned, and we launched it in 2020, which as we all know, wasn't a particularly good year for anybody, in particularly for getting people on training courses. So it wasn't the best year to launch it. But even so, we have had people on courses, and the courses have been really well received. So so that's a brief introduction to TWI, the training and certification scheme at TWI, the plastics welding training certification scheme, and then obviously a bit of background about why we developed the scheme. I'll just hand over now to my colleague, to Tony Grouse, who will kindly give a presentation on the development of the certification scheme and introduce himself.
Good afternoon. I'd just like to get this ready to start. I wasn't quite ready. My name is Tony Grouse. I'm one of the plastic weld instructors and plastic weld inspection instructors at TWI. I've been here now for nearly 10 years, delivering courses worldwide with my colleagues, both Scott and a gentleman called Andrew Knight. We've been to, so far, I think it's 18 or 19 different countries worldwide, delivering the plastic welding courses, and hopefully the inspection side of it is going to take off even further. We do have requests from different companies for inspection. Up until, as Scott says, 2 years ago, there was nothing developed. Now that we've actually got a course developed and we've had the pilot course ran and it's been released, we're starting to get people on the courses. So I'll just like to run this through this presentation on where we went and how we got there from start to finish, if that's all right. Basically, the demand for the skill in inspection is increasing. Now it's increasing worldwide in both metals and plastics. As Scott said, the number of metal weld inspectors who have been asked to inspect plastics, every time they come to us, they ask the question, well, why doesn't anybody do it? So it was one of the things that TWI looked into, and we looked for the appropriate standards that we could actually do it to. Now, looking around the worldwide for inspection of plastics, there were standards which you had set criteria, you had imperfections, but there was nothing in particular for weld inspection. So we looked and we found that the AWS G1.6 was a specification for the qualification of plastic welding inspectors, was available, but up to date, and currently to our knowledge, there's only at least 2 people been through this course. If that's different, I'm using the data that we got when we initially started running the course, and they were both in the USA. We have run a number of courses at the beginning of last year, just before COVID, and we have a number of different number of certified welders now, weld inspectors now, who are in different countries around the world. There's one out in Australia, a couple in Spain, and I believe there's one in the Middle East. And these are people who were through our courses. We have had others in the UK as well. The decision was made not to align it to the AWS scheme because they were asking for more theoretical on the actual questions and the test questions on the question papers. And it was all about roundabout, not specifics. So you're looking at how the process is done. You're looking at the regulations and rules with regards to welding, not specifically plastics. So we looked into doing it ourselves. So the scheme document was based on the existing metal welding of fusion weld inspector scheme. We changed it, we worked out what we needed to do for plastics, and we rewrote the new document, which is now the TWI 2416. As Scott said earlier on, we've got 3 levels, or we'll have 3 levels shortly. We've got level 1, which is the entry level for visual plastic weld inspector. We've got the plastic weld inspector. And then when we get the 3rd one completed, we'll have the senior plastic weld inspector. We're also going to have 3 separate categories for the plastic welding, where 1 for pipes, 1 for sheet or fabrication, and the last one for lining systems. We've mainly done it that because the number of different failures and faults you can get in plastic welding, and they're not all the same, even though they might look similar, and they can cause different failures and different problems. Obviously, the current levels of failure of visual plastic weld inspector. The plastic weld inspector, as we got it there, is the bridging course, which allows current metal weld inspectors to actually transfer the tickets. That's probably a wrong term, but they actually add to their tickets the plastic weld inspector. So they come on board, they take the course that we deliver, and it gives them another level to actually work from. The current categories, as I said, is pipe only at the moment, but we are working on the other levels for the fabrication and for the lining systems. The development of the course took 2 years, and that was the cumulative efforts of around about 12 people in the writing and the production of all the individual samples, which you have to make. That it's easy to make them on site when you do it by mistake, but to actually physically make it in the laboratory with the correct errors and with the problems in, it's trying to find out how to work out how to do it is quite difficult. The pilot course was delivered at the end of 2019, and we had a number of external participants from industry on the course, and they were all quite impressed and enjoyed the course to the extent they learned something that they weren't aware of even in the industry that they're working in. Shortly after that, it was approved by CSWIP, so then we were allowed to start rolling it out as a proper approved course to give to anybody who wanted to come on and take it on, which was in the beginning of 2020. Basically, the course objectives are to identify various imperfections in plastic pipe welds. That can be anything from electrofusion, socket fusion, butt fusion. We didn't go into the manual welding techniques on pipes, but the fabrication course hopefully will actually take that into account and cover those. But also to understand the relevant welding techniques for plastics. So again, looking at butt fusion, learning about the technique, electrofusion and socket fusion, learning about the techniques, and all. On the first day of the course, we actually give a hands-on for the visual plastic welders. They need to understand the need for documentation in welding, so all of the regulations around it. You need to log in of the sample, log in of materials, identification of where things go, the relevant codes and standards that are related to the inspection requirements. So you've got imperfections in thermoplastic welds, you've got the BSEN 14728, and you've got thermoplastic imperfections, the quality levels, which is BSEN 16296. So that they understand what they should be looking at and where they should be able to get these things from. Also, they'll need to discuss it with the client and the installer to make sure that the appropriate quality levels are put in place for what's happening. The visual plastic welding is suitable for individuals who work with plastics or in the plastics industry who've never really done a great deal on inspection. So if you've got a minimum of a couple of 6 months, 2 years of experience physically welding plastic pipe together, you should be able to come through and take the visual plastic weld inspectors course. That will put you on the line or on the track if you want to continue down that route. It also gives companies their own inspection, who could be separate, or it could be a leading hand, or it could be a team leader who understands the pitfalls and the problems now, and then they can actually work through there. The issue is we have the visual needs to work under the supervision of a PWI, which is why we brought the bridging course in, so it gives that second level of authority. So the visual weld inspector and then has somebody who can plan his work and go through from that point onwards. Again, no specific experience required, but it's recommended a minimum of 6 months. It's a 3-day training course and examination, practical demonstrations, hands-on tuition. So the individual gets the chance to actually do butt fusion welds, electrofusion welds, and socket fusion in both polyethylene, polypropylene pipe. They understand the individual welding imperfections that can happen from those. They can actually see them, make them themselves to understand how it can happen. The visual inspection side of it is they're looking at the problems. They can look at each other's welds. They can look at welds that have been pre-manufactured in the lab to try and find the problems and try and understand what can cause it. We look at the materials and quality assurance. So basically, we're looking at helping them understand the types of materials that they're going to be using and the pitfalls of using one against another, and all the paperwork around that. So you're looking at materials that you can actually use with certain liquids, certain liquors, and it's all, what's the word I'm looking for? It's sort of chemical compatibility. The duties and responsibilities of the plastic weld inspector, what he needs to understand, how he needs to respond, and where he needs to go. Terms and definitions, what types of things he's looking for, what to name it, how to call it, and then health and safety. Obviously, health and safety is a major one because people don't tend to think of as weld inspector down the lines of health and safety, but he needs to understand what they could be doing wrong and help them stop it and sort it out. Plastics weld inspector, as you can see, we put bridging course in there. At the moment, we're running it as a bridging course, so the current weld inspectors can come on this course, and we then have that second level of supervision for the visual weld inspectors. We are writing a complete plastic weld inspectors course for the second level, so people who are currently visuals will then be able to take the weld inspectors course and move up to weld inspector. It's suitable for metal weld inspectors or fusion welders inspectors who currently got their certification. So they can come on the course, they'll learn about the materials, they'll learn about imperfections, they'll learn about the welding techniques, and they go through a similar course where it's a little bit more in depth than for the visual. A lot of it will have been covered in their 3.2 or their metal weld inspector courses, and we're just adding on to it the plastic side of it. Manufacture the samples with weld imperfections. As I said a short while ago, 14728 classifies the imperfections that can be encountered in thermoplastic welds. There's 7 groups, as we've listed below, but in those groups there are a multitude of other things that can be part of it. So you've just got to understand how things can be produced. So it can be either done by accident, bad practice, or basically just downright laziness. I'm not saying that people are out there, but things can happen. Cavities, solid inclusions, lack of fusion or penetration, that's a difficult one. You can't physically see it, usually you've got to test it. Imperfect shape, dimensions, and then you've got miscellaneous or surface imperfections that can be not directly due to the welding process, but can be produced by pipes being dragged across an area or a site rather than being carried across on a crane or forklift. Manufacture of certain samples, we basically had to blow things up, for want of a better term. Some of the samples where we've actually found electrofusion fittings where we've got melt coming out of them, we had to work out a way of fooling the equipment to give us higher voltage, longer welding times, to actually physically produce failures and faults. These sometimes replicate what we've actually seen on site, or we've been told or shown in photographs. So it was a case of manufacturing things to produce replicas that have been shown. Again, socket fusion, again, you've got thermal damage, you've got misalignment, you've got incorrect insertion, moisture content, and the bottom right-hand one is an old style failure, which the term we've been told is sheeting. In the DBS, there's 2 different types of fitting that can be used for socket fusion. If you're not peeling the pipe and using the incorrect fitting, that will happen. So it basically, it's like peeling the pipe for you as you push the pipe into the socket or spigot tools. And it's just peeling the outside face of the pipe backwards. It's not specifically an imperfection, but it doesn't look very nice, and it could be classed as unfit. So that would be another one that we can actually look at. Inspection tools, TWI manufacture the Weld Gauge, which is a standard tool that's produced for metal welders. There are others out there that are manufactured by others, but the one we use in the training course is this one. It's to measure depth, misalignment, and you can measure depth of damage in plastic pipes. Maybe not so much on metal, but you can on plastics. The instance gauge, basically it's a 2-foot or 500 mil steel rule with a protractor in the center. We then produce standoffs, so it will actually sit on the surface of the pipe, and it will give us angular misalignment of the pipes, which can be actually within a certain criteria, and you can use quality levels to work those out. And it will do it in a digital form. Inspection tools for hand inspection, you've got vernier calipers. These are ideal for measuring bead sizes. They can also measure, if used with a steel rule, you can measure your misalignment depth. You can measure all sorts of things. General measurement tools can be used in plastics. And then we've got steel rules. Now this is one of the faults that people have on site, is what we call toe-in, where the end of the pipe has actually shrunk. They might have planed or faced the end of the pipe off so it's correct diameter. They bring a new piece of pipe up and the size is actually smaller. The pipe's actually shrunk back due to the plasticization of the material, and it's relaxed itself back into its original, more or less its original size, which could be smaller than as the pipe is. If the pipe is too far out, it then can affect the strength of the weld, and you will get misalignment with it. Go, no-go gauges. These are available from certain places, from certain suppliers. They're just basically a sized slotted piece of metal with individual sizes on it, so it'll actually fit over a bead to give you a yes or no. If you use the WIS specification, you've got large maximum and minimum bead size. This is ideal for that. So all you do is just drop it over the bead, and if it fits, the bead's okay. If it's too small, then you can actually use a smaller one and find out if it's within the criteria. And that's in the WIS specification. On the examinations, we're looking at a 20-question multi-choice paper. This is for the visual weld inspection. It covers practical measurement, visual inspection, acceptance levels, and theoretical information on standards, procedures, and safety. They're allowed 1.5 hours for this, with the pass mark of being 70%. Anybody who has an issue with this, they follow the standard CSWIP procedures. If they fail, they're allowed 30 days for renewal, for repeat. And then again, if they fail after that, they've got to retake the whole course and resubmit the exam, reset the examination. For the Plastic Weld Inspectors exam, so this is the next one up, it's an open book theoretical exam. We use the WIS 43208 specification as a document they've got to work from, and all the questions are taken and used from the WIS. So they've basically got to study this and find out what they're doing. We'd also then have a closed book theoretical exam, which covers procedures, standards, drawings, materials, safety testing, welding processes, duties and responsibilities, everything they should already understand. And we would touch on each one and ask them to give their answers on it. And the last one is scenario based, where they'll be given a number of a sample or 2 samples and asked to do practical measurements on it with the visual inspection within a set acceptance levels, which they'll be handed in the examination. And for the total of that, you're allowed 3 hours for the whole part, for all 3 parts of those examinations. The scenario-based example, the candidate, as I said, will be given a sample or 2. It'll be either butt fusion, left fusion, or socket, with a minimum number of 3 imperfections in it. So when we produce these samples, we have to try and make the sample with, or multiple samples with identical imperfections, which was very, very difficult, given the way that some of these samples can be manufactured. So the client's provided with the acceptance criteria as part of the examination, and he then makes his measurements. As long as he accepts or rejects it, it will then go to his mark and he'll be able to pass or fail. Once he's completed the test report and notes all the imperfections on it. That's an example of the test report that we actually give them. They obviously fill it in with their information, and they'll put their own datum point on it and then work from the datum around the pipe, marking all the imperfections in that they see. As I said, we do usually a minimum of 3, but there's never less than that. If they find more, fine. If they've picked up something that we maybe haven't put on there that might have been put on due to the damage or transportation of the sample. After the exam, the successful candidate receives 2 copies of the certification and an identity card. If he's paid for it, it'll come to him. If the company he's worked for has paid for it, it'll go to his sponsor. The individual doesn't receive it that way. Unsuccessful, they're allowed to retest the examination after 30 days from the initial one. But if they fail that, then they've got to retake the whole course and start again. The proof of validity is the same as the metal weld inspectors. So it's 5 years and then 10 years. We initially were looking at doing it 3 years and 6 years, which was the same as the AWS. But then we decided that if we kept everything the same, when a metal weld inspector's ticket runs out, he can come within the normal time and possibly do 2 or 3 courses on the bounce to make sure that all his certifications are up to date and he has them. What the candidates will learn usually is fundamental understanding of plastic welding techniques and the procedures for welding thermoplastics. They also learn a lot more about the materials, how the materials are produced, how the actual finished product's produced. So looking at the pipes being produced via extrusion, or the materials themselves being produced in a reactor under temperature and pressure to produce the plastic that starts the process off. Ability to demonstrate and practice what they're doing. So they'll show us how to do welds, they'll show us how to do the inspection, they'll be able to practice it and explain what they're doing. Understand the factors that influence the quality in welding thermoplastics. To understand what they're doing, they've got to know about the plastics, they've got to know how things are welded together. They've got to understand the pitfalls of doing that welding and what can happen if they don't do it correctly. So that's inspecting and looking at what's happening when they're actually doing welding. So if they're going on site, watching the welders and going from there. Where am I? Military report on inspection of welds. So that's doing the inspection, writing the reports, passing it back to the client. At the end of it, they receive the CSWIP Visual Plastic Weld Inspectors certificate. That's as long as they pass the course. For the plastic weld inspector, it's all very much the same. They go through the same type of information, the fundamental understanding of plastic welding techniques, ability to understand factors that influence different thermoplastics and how they're welded, interpret drawings. Sometimes in plastics, we don't get specific drawings all the time. And if you're doing a welded plastic install, you don't necessarily have welding drawings on the actual design itself. So you get a drawing which basically shows where the pipeline goes from A to B, but it doesn't tell you what type of welds go on to that pipeline. So it's not a standard welder's drawing or welded drawing. You've got to interpret that yourself to a certain extent and use the best procedures, and then talk to the client, talk to the installer on how to do that. Do reports on inspection, mechanical tests, make sure the tests are, the results are correct. Assess reports that are done by the weld inspector, the visual weld inspector, and confirm the material meets the requirements that have been requested. And at the end of it, the plastic weld inspector gets the CSWIP certificate. So it's a certificate for 5 years that's recognised worldwide. The benefits, Scott mentioned or touched on these earlier on. Inspection is undertaken by skilled inspectors in his first line in defence against poor installation. Now, poor installation means rework, costs more money, and causes more downtime. It also allows confidence in the contractors and the installation teams, because if they know they're being inspected, they're going to work a bit harder and they're going to work and do the job correctly. Not that they don't supposedly do it now, but that some of these jobs I've been on, I've seen things that I would be frightened of, to be honest. Improvement in systems as a whole, a reduction in downtime, so you're basically reducing problems or hopefully failures and reworking. Reduction in maintenance cost, because if the teams put it in correctly, it should be less prone to failure. Enhancement in working practices, potential decrease in insurance. That I don't know, but it would be nice to think it would happen. Production of inspection reports, so the installation that's been produced, there will be a report on all the welded joints. And as I've said, CSWIP certification is recognised worldwide. We are in 18 different places around the world as TWI, and CSWIP's in those areas as well. And that's about it from me. Obviously, if you have any questions, please pass them back through the chat. Thank you.
Thanks, Tony. Thanks to Scott and Tony. We do have a number of questions. I'll claim chairman's rights and start off with mine. Gentlemen, you've given a very interesting presentation on what looks like to be a great scheme, very important scheme, particularly from the industry that I spent many years in, the water industry. Please don't take this as a criticism of the of the Welding Institute. But how has it taken so long for us to be in this position that you now have a proper training scheme?
Should we answer that, Tony? Yeah, that's fine. That's absolutely fine. That's a good question, Dave. I mean, obviously, to develop these schemes, it's a reasonable sum of money to develop these schemes, and obviously we have to justify that to obviously the powers that be at TWI. And over time, obviously, the first thing we did was develop the Weld Training and Certification Scheme, which we did over 20 years ago, which has been a success for TWI. And I think this has been a follow-on from that. But I think you're right. I think this has been needed for some time. I mean, if you see the numbers of metal welding inspectors that we go through our courses on a yearly basis, I can't remember what the figure off the top of my head, was it 9,000 I mentioned? Something like that on an annual basis. They're inspecting metal joints in pipes. Then why are people not inspecting plastic pipes the same way? So it is something that's needed. We've spent 2 years developing it, working with industry on developing the scheme. So it's so at least I think we're there now. We have something that we're happy with, and obviously we'd welcome anyone from the Pipeline Industries Guild to attend and to give their feedback as well from the course. That would be greatly appreciated. The course is still in its infancy, I should say. So it was only launched last year. So the more people that attend it, the more feedback we can receive, and obviously we can change it accordingly if we feel it needs to be done. But yeah, it's a good question, Dave. Obviously, we should have had it a while back, but hopefully now we have it, that people will start adopting it and using it as they should.
May I ask you something? Sorry, David. I believe personally that one of the reasons why it hasn't been pushed before now is in plastic welding, it's not mandatory to have. Metal welding, it's mandatory that you be certified, but plastic welding, it isn't. So the fact that we have people out there who are non-certified welders putting pipelines in, there's nobody to inspect it because it's not a mandatory thing. And now that we've brought this in, more people are starting to ask for it. So there's a chance that it actually might move forward and become more akin to metal welding, where everybody has to be certified to weld or to do certain welding in the future. I would hope that would be the case.
Yeah. Thanks, Tony and Scott. I guess actually, if you looked at the history of metal welding, it probably was many years before there were the various certifications that are now in place for welding quality on those as well. On a similar theme, we've got a question from Joe Parker. You've mentioned water. Does any water supply organisation or service provider to such an organisation have people who are identified as inspectors who have accreditation?
Not as far as I'm aware, Dave. Not as far as I'm aware. So, I mean, whether they have inspectors there, but I wouldn't be sure on what certification they have. Obviously, because there isn't one. This is the first one for plastic pipe weld inspectors. So, yeah. So, not to my knowledge, Dave would be the answer to that.
I just wonder actually whether associated with is another question, which is, well, are you finding that the water industry is actually requesting or sending people onto your courses?
No, but I'm hoping that now more people know about it, then that may be the case, I think. I mean, from my point of view, from TWI's point of view, we're the reason we developed it is because we know we feel there's a need for it. We wouldn't be allowed to do it otherwise, and some of the feedback that we're receiving would back that up in terms of, I mean, obviously we train and qualify welders, which is great, and that's one step. But to have an independent inspector inspecting joints on certain jobs, I mean, I'm not saying for it may be necessary on every job, but certainly on certainly on the majority of jobs, why there shouldn't be an inspector inspecting the quality of those welds to ensure that it's done correctly, safely, and to the required standard. And like some of the points that Tony mentioned, to avoid the costs of poor jointing, essentially, which is
yeah, absolutely. Another question here from Chris Kowalski. Would you agree that training is the first line in preventing poor jointing rather than inspection?
Yes, I think that's true. That is correct. I think, I mean, obviously training in an ideal world, Dave, I think we'd have everybody that's installing plastic pipe to be fully trained and certified and have lots of knowledge, and everyone doing it correctly when they're out on site. I mean, we see this across all of our training and certification courses, whether it's for membranes, whether it's for plastic pipes or sheet or fabrication, that you can train people, you can certify them. That doesn't necessarily mean that they're going to go out there and do the job to that standard. And we've seen it. And it's also economical pressures and financial pressures on people when they're doing these jobs. When they go out on site, it's very easy to cut a call time on a butt fusion weld. It's very easy to do these sorts of things in certain situations to reduce the quality of the welds. And if you have an inspector there monitoring that and inspecting the quality of the joints, then the risk is significantly reduced of poor quality jointing. So yes, I would agree with that. Obviously, in an ideal world, trained and certified welders and supervisors and designers and all these other things that are involved in the pipeline process would be perfect. But we all know, even in that case, there's still poor quality jointing going ahead. We know that's the case.
Yeah, thanks. So a supporting comment here from Nick Preston. Yes, Chris, a trainer, welder, designer, and their supervisors. So, and I think that's very important. As a previous designer, I certainly had training in welding as well. Next question from Mike GPS. Does the training cover just PE welding, pipe welding, or does it cover other plastic pipe materials?
We
definitely cover PP
and PE. So it's both polypropylene and polyethylene we cover, but we can discuss other materials. I know that polyamide's actually coming in into the fore a bit more. We cover PVC a little bit, and we can also talk about some of the fluoropolymers like ECTFE, PFA, FEP. It depends on the course, who's there and what they want to ask. We can't specifically give them the certification to cover those other materials, but nominally it will be polypropylene and polyethylene. But we can discuss and explain other things as well.
I think it's important to mention as well, Tony, that obviously the inspection techniques for butt fusion, electrofusion, and socket fusion are the same. Yeah. Whether they're obviously the pipe materials are different. So the inspection technique and methodology and report writing are all the same. Although we do focus on polypropylene and polyethylene on the course, because I guess that's the largest market share, and there's more of that being installed than some of the other materials currently. But we do have, obviously, we're aware of a lot of other materials that have been welded. So we would, yeah, Tony's right. We can touch on that, I think, if the client requires it.
Okay, thanks. Next question from Nick Preston. Tony, do they have to do or a visual witness, I think probably means witness, a bead bend back test from a butt fusion weld?
No, what we do is we teach them the welding processes. So we don't do the bead bend. That can be shown if they request it, but it's not one of the inspection techniques because that's the destructive testing. And the only way to do that is to physically cut the bead from the weld, then twist it to see if you get any delamination between the beads. It's not a be-all and end-all test. It's just a guideline test.
Tony, do we touch on all the non-destructive testing techniques as well for plastic pipes, such as phased array ultrasonics and some of the other ones that people use?
Yeah, we do touch on a lot of those testing techniques in the course when we're actually delivering it. Yeah.
Yes, so I think although we don't actually teach people how to do that test, or
we do actually, when we're doing plastic welder training, we actually go through them we explain all about that test when we're doing pipe welder training. So we show them about it, we explain about it. We don't necessarily do the test, but we can actually, if they want to, we can do it. That's not an issue. Sorry.
Associate that with that, I'm just thinking of something coming from myself. Actually, does that mean that the beading process and the bend back test isn't really being done or isn't favoured these days for quality testing?
It's not normally a test that's done. Sorry, Scott. It's only down to clients' requirements whether they actually take the bead off or they do the bend back tests. A lot of clients don't require it, especially on the outside of the pipe. They do require it on the inside, so that stops the likes of slurry and blockages can build on the bead areas. Yeah. So to actually do a bend test on the inside, it's difficult when you're trying to get the bead out. because it can be seriously damaged on the internal. As against the external one, it's easier to remove, but it's not always done. It's only in specific jobs where the client requests it that it can be done.
Okay, thanks.
Dave, I think it's important just to mention there that with all of these test methods, there's always some limitations. So even with visual inspection, there's only so much you can see and only so much you can inspect from a visual inspection, and then from a bead back test, and also from a non-destructive phased array ultrasonics point of view, or any other method of non-destructive testing plastic pipes, they all have some limitations with their inspection techniques. Obviously, phased array is slow and expensive. Visual inspection is quicker, but doesn't pick up everything. For example, inclusions inside the wall of the pipe. All of these things will have their uses and benefits, I think. So certainly, from our point of view, visual inspection is the one that you can do easily and quickly, and it should be done on most jobs. I think, but then some of the other methods of testing the welds you can use as well as.
Okay, thanks very much. Another question here from Kate Byfield. Can this course be done online?
Not as yet. We have been in discussions with our IT department with regards to putting the course online. We haven't, due to it only been released last year, we haven't got to the stage where we can actually do it that way yet. But we are looking at the possibility of doing this. I'm not saying we won't be, but we are looking at the possibility of being able to do it.
Okay, thanks. Question, all right, it's probably more a comment here from Macduff's to us all. Usually, when we have a problem, we send the pipe away to get a report on why it failed.
Was it
hopefully this system will prevent you getting that stage. So hopefully with trained welding inspectors and trained welders and other people, then obviously we can hopefully will certainly significantly reduce the risk of these failures occurring. I mean, obviously we can't eliminate it. I'm sure that's not possible, but we can significantly reduce the risk. Absolutely.
Yeah, excellent. Thanks. Another question here from Mike GPS. Utilities normally call in the manufacturer, GPS, obviously, when there is a welding issue, and we inspect and advise accordingly. The inspector training course is a great step forward. So well done, compliments there. And also another comment from Mike, external bead testing is part of the industry standards. I haven't seen a utility not require this.
I've trained people from different water areas around the country, and none of them have talked about bead testing. When we discuss it, some of them turn around and say, "Oh, we never do that." So I think it depends on the area and the client's requirements.
I think this goes back to some of what we were saying earlier, Dave, and somebody, Mike as well, for answer to the question, is that obviously we, in best practice, and certainly people should be doing these things not necessarily always doing these things, I think is, so it's certainly important for inspectors. Yeah, we're certainly aware that people should be doing them. But we don't tend to cover that aspect on this particular course. We cover, say, all the test methods, even including destructive testing, including like wasted tensile and creep rupture testing of plastic pipes. But obviously for the visual inspector course, it's more of what can people do from a visual inspection point of view and a measurement point of view to inspect not just butt fusion, obviously electrofusion as well, where obviously those sorts of tests aren't available.
Yeah. Okay, thanks. Oh, another one here, another question. Is the plastic, this is from Kenny Watson, is the plastic or metallic weld inspection course more relevant to emerging technologies for hydrogen gas distribution pipeline? Well, that's something off the headlines there. Any thoughts on that?
No,
hydrogen.
I think it's just relevant to the installation of plastic pipes. It doesn't matter where it is or what it's used for. It's something we've been looking at. It could be for water, it could be for oil, gas, it could be for waste. It doesn't matter. As far as we're concerned, as TWI, we're looking at the inspection of any plastic pipe that's welded, and to try and improve the business basically.
Excellent, thanks. And finally, a comment from Chris Kowalski. Bead removal is stated in WI 43208. You advise persons are tested against. So that's the water industry standard. Question from Mike Ahern. Do you have costs for these courses?
We do. It's they're available on our website, on the TWI training website. We have course scheduled in for the whole of 2021. So I feel it's probably the easiest place to go and have a look. There's some more information about the courses on there as well. So in terms of the TWI training website, you can go on there and get an idea of it's actually priced per candidate, and most of the courses are run at TWI Cambridge or in TWI Middlesbrough. So if you want to go on there and have a look, and if a company, for example, wanted to run a bespoke course and get Weld Inspection certification, then we could quote that separately. Sure. If they had a number of people, yeah. Okay,
thanks very much. That's the end of the questions. Comment from Nick Preston. Thanks for your insights, guys, from the TWI Go. And then, yeah, Kate's really reminding us that we're actually running out of time now. So thank you for everyone. Thank you for particularly to Scott and Tony. If there are any further questions, then Guild Headquarters will be in touch and we will email out the questions. But thanks for everyone for attending, and I hope you found it all useful. And now I think we're going to, we'll be losing our links any second now, I'm sure.
Thanks.